So welcome everyone to the National Robotarium Robotics and Autonomous Systems Lab stream. So we're currently in what we call our RAS lab, which, as you might guess, Robotics and Autonomous Systems. With us today, we've got an excellent and quite eclectic group of people when it comes to both knowledge, background, and what we actually do within the Robotarium. So I'm just going to pass around. Everyone's just going to say who they are, what we do a bit, before we then get into the really good, interesting stuff, which is when you actually get to explore our lab a little bit and use some of our robots.
Hi, my name is Marta Vallejo. I'm an assistant professor in the School of Mathematical and Computer Science, and my background is in data optimization, machine learning, and deep learning.
Hi, folks. My name is Blair Wilson, and I work at the Robotarium in the Industry and Schools Engagement team, and I will also be your spot handler for today.
Hi, everybody. I'm Sabat Bashir, and I also work at the National Robotarium as part of the Industry and Schools Engagement team.
Hello, everyone. I am Emanuele. I'm a PhD student in the Edinburgh Centre for Robotics, and I'm working with robots and autonomously decisions making, and I'll be working behind the scene now.
Hey everyone, I'm Jonah. I'm a first-year PhD student, mainly focused in bio-inspired software robotics, and I'll also be sort of behind the scenes.
And I did just realize that I introduced the room, and everyone else introduced themselves, and I introduced myself. My name is Alice McConnell. I'm an assistant professor in mathematics and computer science as well, primarily with a background in healthcare robotics and soft robotics as well. And I will be the general person running around today after the robots, making sure things hopefully work. At the National Robotarium, we really do a huge variety of robotics. We've got work in human-robot interaction, in healthcare robotics. What you're actually seeing just now is some of our more industrial robotics, some of our agri-tech robotics. So we do work now really like how can we use robotics and automation and AI to improve, say, the yield of farmers' crops. In this case, actually, what you're seeing is our Husky platform actually deployed in the field, being used both for actually manipulation and even some soil sampling as well. And it's probably one of our muddiest robots to date. We've also been using it a bit for mapping. So this is something where our LiDAR system that we have on top, if you wonder what is spinning on our robot, then it's something which we do use to actually do mapping and navigation. Now you can see our Spot robot. Now, this is the top-down view that you're going to be seeing quite often today. We actually do have a couple other views that we will be showing you as well, integrating so you can see live both what the robot sees, not the Spot. One of our other robots will be able to see, and you'll also be able to control that robot as well. So you'll get a really quite interesting and fun experience that we hope. What the Spot is doing currently is very carefully navigating its way around a small assault course that we set up for the robot. And what we're wanting people to do is we're going to give you a chance to join and follow exactly what the Spot's doing. So you get to go around the same route. You get to go back. You don't have to do it in reverse. This is our robotic operator showing off his skills. Fantastic. Now, if you can move Spot just to the side a little bit so we have some clear room. Perfect. And maybe we'll get Spot to sit. Okay. So what we're now going to do is in the chat, we will post a link. If you would like to join it to control one of our robots, all you have to do is click on the link. Okay, now you've managed to extend it all the way up. You should hopefully have a good view of the whole area pretty much. And your objective is to be able to follow what the Spot was doing before, but you'll actually be able to see on the ground. It's the great thing from the view you can see is a mark on the ground. So we've taped out an exact route. And so what you need to do is just use your arrow keys to guide it about. So this is something that you might have wondered why I got Blair to do this and why we're showing both the Spot and the double robot as well. And I want you to have a think when we've said about telepresence robots before, really the difference here. So while Spot has a big manipulator on it, it is fast. Our double robot is not as fast. It can do quite good in a straight line. It doesn't have a manipulator. They've both achieved the same goal within maybe a minute's difference. But I want you to have a think. Which one, potentially, would you prefer to have in your house to maybe care for you and to walk around your house? For me, parts of my house are quite small. I feel that the double is definitely a lot less intrusive and a lot safer, I would say, in that kind of context to work with. But if I need something picked up, if I drop something that I can't get, well, that's really when we need the Spot. So it's a different robot for a different situation.
I'm going to talk about my experience so far doing my PhD. I'm only a year in, or one academic year, not even a full year. So this is sort of a very naive perspective of it so far. But honestly, so far, it's been an absolute dream. When I was finishing my undergrad in mechanical engineering, I knew that I wanted to do something where I'd have a lot of freedom to work on a lot of different systems, because I'm sort of a jack of all trades, master of none. And so I wanted something where I would get to like have a lot of involvement with sort of every aspect of a project. And I was looking at potential job openings, and none of those really applied. A lot of jobs sort of siphon you down one specific path, which I didn't find particularly exciting or appealing. I knew I wanted to just sort of like play with the robots and sort of make exciting things. And a PhD so far has been that. It's been a lot of fun just sort of getting to be in the lab and build things that I want to build in the field of robotics. So I've been enjoying that.
Yeah. Hello, everybody. Yeah, as I said, I'm Craig Hamilton. I'm a second year PhD here. My research is on neuromorphic sensing, which is a very big word for a very different style of sensor. Typically on robots, what we have are cameras or LiDAR. And with a standard camera, you get an image at a fixed rate every 30, 60, 1/60th of a second, say. But with neuromorphic sensors and event cameras, what we're actually getting is a continuous stream of events that are like little pixel level changes in the environment. So if something gets brighter or darker, or if something moves through the environment. And what we're trying to do is leverage this with other technologies to try and create different modalities for sensing the environment. So right now, my main focus is on 3D depth estimation using a laser. The idea behind this is that we could use it in applications where LiDAR might not be as usable, such as in underwater robotics. Because we're able to use a visible light source with the camera, we're able to get much better ranges than a LiDAR underwater. And we should also be able to get much faster data rates from it, because we're not having to scan the whole scene. We're actually only scanning a very little part of it, the part that actually matters.
So, Craig, do you think that would be particularly useful in some of these teleoperations situations if you're able to compress the sort of data that's being conveyed across? So you don't need like a full video stream that's sort of having to be compressed. Do you think that would be potentially useful in teleop?
Yeah, so something I've looked at in the past is something known as compressive sensing. So you have very limited visual information to work off of, and you're trying to reconstruct the full image from that very limited information. So you might only have like 4 pixels of usable information, and trying to pull out a very large image from that using some understanding what's in the environment. So what you can do there is, if you do have a camera that's able to produce high resolution images, but you want to limit the amount of data you send, you can run basically a reverse of that algorithm to compress the data down to only data that you would need to then reconstruct that image at the opposite side. So you'd be limiting your image from megabytes in size to potentially only 10 bits of information, send that across, and then reconstruct it. What that requires, though, is at either end you have to have some form of computation, which isn't great because the compressive sensing algorithms do require a lot of algorithmic work in order to actually get usable images back.
I'd like to thank everyone who's come along and tried our robot, asked us questions. It's always great to engage with different people and just see what curiosities everyone actually has in different questions. Hopefully we've answered them to your satisfaction. You've enjoyed the activities we have here. And yeah, it'd be great. We quite often have open days. We have different ways we can engage. Please keep an eye on our any of our Twitters, on our social media, on our website. See what we're doing. Come along and join us. We're always happy to answer any kind of questions. So thank you all for doing things. And yeah, I realize I'm blocking a few people here. I should definitely not sit at the front. But yeah, thank you everyone, and we'll see you later. It's great. Bye.
Bye.